afternoon, students. Today we are going to discuss salt hydrolysis a bit further, right? So if I take a question, let us say I take CH3COO this is a salt. Now if you see, this salt comprises of a part of weak acid, that is CH3COOH, and this part, the ionic part, has come from a weak base, that is NH4OH. Now if I say write its hydrolysis equation, I can easily write this is the weak part undergoes hydrolysis, right? We know that. So this corresponds to Ka, this corresponds to Kb, this corresponds to Kb, and thus you multiply it with Kh, and thus you get Kw. So this is very neat to understand. You can easily write the equations, right? So once you have written this, we are going to move further. Now, as I was discussing in the previous video about the pH or the pOH, we had known that we had taken a salt such as NH4Cl, its hydrolysis, and we had taken up the issue like this. We got like this, right? So now we had also got this, that we knew that Kw was equal to Kh into Kb, or you can also write that Kh was equal to Kw by Kb, right? The hydrolysis constant of this salt, right? So now from here, if I move on from here, if I take this equation on one side, so I can easily write it. We got that the first point is that Kh hydrolysis constant is equal to Kw by Kb, right? This is no rocket science. You can easily find it out. Next, if you see here, if I take the concentration to be C molarity at T is equal to 0, and this is initially excess. If I take water to be excess, this is 0 and this is 0. Now if I say T is equal to T, this becomes C minus C alpha. Why? Because this is not going to be 100% dissociated, it's a weak base. Now, if I write it from here, I can easily get C alpha and then C alpha. Now here I can make it out that Kh corresponds to C alpha into C alpha by C into 1 minus alpha. Now if you see, students, you get C alpha square by 1 minus alpha, right? Okay. Now generally in most of the cases, if alpha is less than 10%, you can neglect the denominator, because since when alpha is less than 10%, there is no role of the denominator. 1 minus, let's say alpha is 1%. So 1 minus 0.01 is 0.99, almost equal to 1, right? We take it up to 10%. So if alpha is less than 10%, by default, Kh becomes C alpha square. Remember this point. If alpha is greater than 10%, or if it's by default not given, then we take it as this, right? So if I take the by default case, that is alpha is less than 10%, so what do I get? I am going to get Kh is equal to C alpha square, and I get alpha as root over Kh by C. It means degree of dissociation of a salt of a strong acid and a weak base is proportional to, inversely of its square root. That is inversely proportional to square root of its concentration, right? Now, if I move further from here, right? If I check from here, I got alpha, I got Kh, right? Now, I need to find out H plus concentration. I know from the equation H plus was C alpha. Now students, if you see and check it out, you can easily substitute the values. You can get C into root over Kh by C. Now it's very easy from here. You can easily write root over, this C goes inside, C square and C gets cut, and then you get Kh into C, right? This is what you get as H plus. Now students, if you move further from here, what do you get as H plus? This is your H plus, and you can substitute the value of Kh here, right? So you get H plus as root over Kw into C by Kb. This is what you get as H plus, and thus you can easily write the pH as half of Kw. Negative. We are going to take the negative log. If I am going to take it through a step, this becomes pH, and this becomes negative log of Kw into C by Kb. To the whole power 1 by 2, right? This 1 by 2 comes out, and thus the working, that is minus half of, this half comes down, and then you get log of Kw plus log of C minus log of Kb, right? And thus, you know, this we can put this minus sign inside, we can put this minus sign inside, and thus minus log Kw is pKw. So I can easily write from here, we can write it like this. You just check it out once here. Did you check it out here? This equation? Now from here you need to move here, right? You see, pH comes to be around half of this minus log Kw becomes pKw. This minus log C is minus log C plus log Kb becomes minus pKb, and this is minus log C, and you get log C, right? Now see students, at 25 degrees Celsius, the value of Kw is 10 to the power minus 14, and thus the value of pKw will be 14. So half of 14 is 7, so you get pH is equal to 7 minus half of pKb. You know, I have taken minus common plus logs, right? I have taken minus common here, right? Now students, if you see and check it out, just see. Something is being subtracted from 7, so the pH will automatically be less than 7. So you need to make it out. So if you understood this, it will be very similar and interesting for a salt of strong base and a weak acid. Now if I replace it like this gets replaced by Ka, right? This remains the same, and here you need to find out OH minus because it is a strong base salt. So OH minus becomes C alpha. Here you get OH minus as this, but remember students, this becomes Ka because the acid part here is weak, and thus this becomes Ka, right? This becomes Ka, and everything is same except for this, and this becomes POH, right students? This becomes POH. And the pH should be less than 7 because it's a strong base. So here I write pH. So it's very simple to derive, and you can derive it very easily, right? And then comes the part for the salt of weak acid and a weak base, right? Now you see. If you check for the salt of weak acid and a weak base, you need to understand this. See, check it out. I took a salt of a weak acid and a weak base. So I took this salt. Now you need to remember this salt when hydrolyzed goes into CS3COOH plus NH4OH, right? Now for a moment, think about it. At T is equal to 0, this was C and this was excess. I took it to be, I generally take it to be excess. This is 0M and this is 0M, right students? Now if you see at T is equal to T, and the degree of dissociation is alpha, of course. So this becomes C minus C alpha, this becomes C alpha, and this becomes C alpha, right? So here if you find it out, it becomes a bit difficult for students to derive the equation. Now here you check it out once, right? This was the equation. Now students see, if you find it out here for this particular thing, just check it out once. You can't make it out which is going to dissociate or which is going to not. And this is where you make a very common mistake. Just check here. In this case here, if I write it like this, you are making it an early attempt to initially write the concentrations. Just for a moment think about it. This comprises of two ions which are weak, so both of them are going to hydrolyze, we don't know yet. So here what we are going to do, CS3COO minus plus NH4 plus. What did we follow? We followed a very basic concept that a salt when dissolved in water dissociates, and thus we write H2. Now here if you find it out, it will be much easier for you. And you can go further, right? So from here you went further, and then here you get C at T is equal to 0. If you write T is equal to 0, you get Cm, this C polarity, this is excess, and this is 0 and this is 0. Now if I write at T is equal to T, degree of dissociation to be alpha, you get C minus C alpha, then I get here C minus C alpha, here this is excess, this is C alpha, and this is C alpha. Now this is the hydrolysis of a salt. If I write KH, and this is C alpha into C alpha by C into 1 minus alpha whole square. So here C gets cut down, right? And this remains as alpha square by 1 minus alpha whole square, right? Now again, if I say alpha is less than 10%, you can immediately write if alpha is less than 10%, you can neglect the denominator, and thus you can get alpha as root over KH. Now students, check this out. Here, the degree of dissociation of a salt of weak acid and a weak base is independent of its concentration. And thus further, you need to find the pH and the pH, right?